Hello students. So as you know, in the alternating current chapter, we are dealing with the concept of transformers. Okay, so in the last class only, we have discussed the introduction part of the transformers, where we studied how the transformers are. Means we started with the definition of transformers, and we studied about how it is constructed, and also we studied about how it works, and we saw some types also. Means step up transformer and step down transformer. Okay, all these things we have covered in the last class. Okay, and also I told you about how the transformation working theory of the transformations. Means by considering the input powers and output powers, the ns and np, es, ep, like that, all the things we considered. And we also studied about the efficiency of the transformer, that is eta. Okay. Okay, so in the last class only I told you, means for an ideal transformer, means only the ideal transformer is having the 100% efficiency. Only a ideal transformer can have 100% efficiency. But in reality we have the efficiency in the range 90 to 99%. We don't have actually 100% efficient transformer. We have, in practical, we have 90 to 99% efficiency only. That means what? We are having some losses also. Means if there is no perfect transformer with 100% efficiency, means 1% is deficient, or 10 90% means what? 10% is deficient, means what? That much amount, 10% or 1% amount, we are having the loss, we are having the energy loss in the transformer. Yes, so that's what I am going to discuss in today's class. So today we are studying about the energy losses in the transformer. Okay, so today we are studying about energy losses in the transformer. Okay, there are so many types of energy losses are there in the transformer. So the first energy loss in the transformer is copper losses. What is the first loss? First loss is copper losses. Okay, second is flux. Second is flux leakage loss. Okay, and the third type of loss in the transformer we have is iron losses. Okay, in this also we have two types that we'll discuss later on. And at the last we have losses due to vibration of the core. We'll discuss all these losses in detail one by one. Okay, so but what is the first loss in the transformer we are getting? Copper losses. Next is flux leakage loss, iron losses, and losses due to the vibration of the core. Okay, let's go one by one. Okay, so what is meant by copper losses? Copper losses. Okay, as you know how the transformer is constructed. Try to remember how the transformer is constructed. We have two types of coil. In between we have one iron core over there, and we have the primary coil, and we have the secondary coil. Means roughly I am telling. So in that transformer, what we have is the primary and secondary coils are linked with each other. Means I'll show you a diagram. See. Okay, so like this, see here, see in this diagram. Okay, so what we having here? Here we have a primary coil, here we have a secondary coil. This is what diagram of the transformer. Okay, see here. Okay, in the transformer diagram we have one primary coil and we have one secondary coil. Okay, so as you know, these primary and secondary coils of the transformer are made up of what? Copper wires. These two coils are made up of what? Copper wires. Okay, and these copper wires are having the resistance. That copper wires are having the resistance. So what happens when current I flows through these wires? In transformer, what happens there? Current is flowing in these two coils, na? So as you know, primary coil and secondary coil are made up of copper wires. So in that copper wires, we are having a resistance. In the copper wire, we are having resistance R. So what happens when current flows through these copper wires? When current is flowing, there is resistance, and in that, if current starts flowing, there takes place a power loss. Yes or no? Means in this copper coils, the current I is flowing, but as I told you, in that copper wire we are having the resistance R. So that resistance will oppose the flow of the current in these coils, isn't it? That's why there occurs a power loss, and this loss, and that loss which takes place in the coils of the transformer is called as what? Copper losses. This loss appears as the heat produced. Okay, as I told you, in the first primary and secondary coil we are having the copper coils, and in that copper wires we having the resistance R. So because of that resistance R, whatever the current flows in these copper wires will feel a energy loss. Okay, that takes place as a power loss, and that loss is coming out in the form of heat. That loss, whatever happens in the copper coils of the primary coil and secondary coil, is appearing as a heat. Understood? And that is nothing but the one type of power loss, and that power loss takes place because of the copper coils, copper primary and secondary coils. Hence it is called as a copper losses. Okay, so how can we overcome the copper losses? Is there any way to overcome the copper losses? Yes. How means? See, in this primary and secondary coil, if you use thick wires, if you use still more thick wires in this primary and secondary coil, you can overcome the copper losses in the transformers. Understand? So this is what the copper losses in the transformer. Okay, done. Second is what? Flux leakage losses. Flux leakage losses means flux leakage losses. Okay, so for that you can refer this diagram. Okay, what happens in the actual transformer? There is a coupling between primary coils and secondary coils. Yes or no? So this coupling between primary and secondary coil is not perfect. Primary coil and secondary coil coupling is not that much perfect. That means what? The magnetic flux linked with the primary coil is not equal to the magnetic flux linked with the secondary coil. That's why there is no perfect coupling, because the magnetic flux of primary coil and secondary coil are different. Okay, so because of that, some amount of electrical energy supplied to the primary coil is wasted. Understood? Because of the imperfect matching of the primary coil and secondary coil magnetic flux, there occurs some amount of energy loss. There occurs some amount of electrical energy loss in the primary coil. Understood? So this is called as what? Flux leakage losses. Because of the difference, or because of the imperfect balancing of the magnetic flux between primary coil and secondary coil, we will get some electrical energy losses, and that is called as what? Flux leakage loss. Okay, so this is about what? Flux leakage loss. Okay, next comes iron losses. So in this iron losses we have two types. In the iron losses we have two types, that are, in the iron losses we have two types. What are those two types means? First is eddy current. First is eddy current losses, and second one is hysteresis losses. Let's go one by one. Okay, so in the third loss, in the iron losses we have two types. In that, first is eddy current losses. So what is eddy current losses means? When in any transformer we are having cores, means how means, in the transformer we are having the layers. See here, like this. See here, like this we are having the some cores here. Cores means, see here, like this. In any transformer the cores will be like this. Means the single cores, one single plane is attached with so many. They are linked with each other and fully they have formed one laminated core. Understood? That's what I am showing in this diagram. See here, laminated core. Okay, so when in this core of the transformer, when in this, means this is primary cell, this is secondary cell, and so many single planes are attached with each other and they have formed one laminated core. Understood? So in this laminated core, when magnetic flux is there, in this primary coil and secondary coil we are having the current, hence there is a changing magnetic flux taking place. Okay, so when this changing magnetic flux linked with the core of the transformer changes, what I am telling, listen to it carefully. When a changing magnetic flux links with the core of the transformer, when the magnetic flux linked with the core of the transformer changes, there are currents are setting up. When the magnetic flux linked with the core of the transformer changes, currents are setting up. Which type of currents are setting? Eddy currents. Which type of currents? Eddy current. Okay, so what I am telling, when there is a change in magnetic flux linked with the core of the transformer, eddy currents are set up in that transformer. Understood? These eddy currents in this core, these eddy currents in the core, in the laminated core or in the iron core, you can say, they will produce some heat. That eddy current which is producing in this laminated core will produce some amount of heat, and that heat will leads to wastage of the energy. Understood? So that wastage of the energy which is produced because of the eddy currents producing in this laminated core are called as what? Eddy current losses. Understood? So what are eddy current losses? So whenever the magnetic flux, linked with the transformer changes, there happens a production of eddy current in the core. Listen to it carefully. When magnetic flux linked with the coil changes in the laminated core, eddy currents are producing, and that eddy currents are producing some amount of heat in the iron core or in the laminated core. Because of this heat there occurs some wastage of energy. So that energy which is produced because of the eddy current is called as what? Eddy current loss or eddy current energy losses. Understood? So this can be reduced by breaking the breaking the course means in the diagram I showed you, means the course is like this na. The course is means so many single planes are attached with each other, and they have produced a core over there. So in this core only we are having the eddy current. So if you break this course into single pieces, means if you break them into single pieces like this, you can overcome this eddy current losses, because eddy current will produce in the core only. So if you break those cores into single things, there is no eddy current. So you can overcome this eddy current losses by breaking their paths, by breaking the cores into single paths. Understood? Oh, this is the first type of iron loss. As I told you, we are having third type is iron losses. In that, first part is eddy current losses. So what is the second one? Second comes is hysteresis loss. Second comes is what? Hysteresis losses. Second part in the iron loss is hysteresis loss. So what is hysteresis loss? So what is this hysteresis loss means? As you know, in the transformer we are having one primary coil and one secondary coil. Okay, so what happens if the current starts flowing in this transformer? If the current starts flowing in the transformer, so first it is we are producing the alternating current to the primary coil of the transformer. So when current starts passing through this primary coil, the iron core, whatever, as I told you, like this laminated core, so this is what? Iron core. So here, when alternating current passes through the primary coil of the transformer, the iron core of the transformer is magnetized. Means what? Because of the flow of current, there occurs a magnetic flux. There occurs a change in magnetic flux. So as you so once what happens? Once it is magnetized, it is magnetized. So if there is a no flow of the current in this coil, means that iron core will demagnetize. Means this process continuously takes place. If current flows, the iron core starts magnetizing. If there is no current flow, the iron core starts demagnetizing. Means this process of magnetizing and demagnetizing will continue in the form of a cycle. Means once it is magnetized, another it is demagnetized. So this magnetizing and demagnetizing takes place over a complete cycle. It takes place over a complete cycle. So some energy is lost in this magnetizing and demagnetizing of the iron core. So this energy loss in a complete cycle is equal to what? Area of one hysteresis loop. This whatever loss is taking place, means whatever the energy is lost in magnetizing and demagnetizing the iron core, the energy loss in this complete cycle is equal to what? Area of the hysteresis loop. So such losses are called as what? Hysteresis losses. So how can we overcome this hysteresis losses now? So this can be overcome, or this can be minimized by using the suitable material. By using the suitable material having a very small hysteresis loop. Loop means what? Like this, one full cycle. So if you use a very small hysteresis loop material, so you can overcome this hysteresis losses. If area of this hysteresis loop is very small, there is a small energy loss, or you can overcome, or you can minimize the energy loss, hysteresis loss, by using a suitable material having narrow hysteresis loop. Okay, so this is about what? The iron losses, eddy current losses and hysteresis losses. Okay, so the last thing is losses due to vibration of the core. That is very simple. So in this, whatever we are having the transformer, that transformer will produce some noise. The transformer will produce some noise. Why it is producing the noise? Because of the magneto restriction effect. because of the magnetostriction effect. So what is the fourth loss is vibration. So that vibration means what? The transformer is producing some sound. Why it is producing some sound? That is because of magnetostriction. That is because of magnetostriction effect. That means what? The in the transformer, whatever the layers are there, the transformer, whatever the layers are there, they will produce some noise because of the vibration. Because of the vibration of the layers, the transformer will produce some noise, and that is magnetostriction effect. So because of this magnetostriction effect, some electrical energy is lost. Because of this magnetostriction effect, some electrical energy is lost in the transformer, and that energy, whatever the energy loss takes place, that is in the form of mechanical energy. Because as you know, vibration means what? Any object, if it is vibrating like this, that is mechanical work it is doing. So this loss takes place in the form of mechanical energy. Okay, so that mechanical energy loss is because of the vibration of the core. That is vibrational losses. So as you know, in the so I'll once again I'll repeat all the things. So totally in the transformer we are having four losses: copper losses, flux leakage losses, iron losses, and losses due to the vibration of the core. So what happens in the copper losses means, whatever we are having the transformers, they are the coils, primary coils and secondary coils are made up of the copper wires, and that copper wires are having the resistance R. So when current I flows through that wires, the power loss takes place, and that too takes place in the form of heat. So this is energy loss because of the copper wires. Next means, in the transformer we are having the primary and secondary coil coupling, and that coupling is not perfect because the magnetic flux in the primary coil is not equal to magnetic flux in the secondary coil. Because of this, some electrical energy is lost, that is called as flux leakage. So next is iron losses. We have eddy current. So in the eddy currents, what I told you, in the transformer, if the magnetic flux is changing, so in the laminated core there is a form of eddy current. So because of that eddy current, it will produce the heat. So that is takes place as a energy loss. We can overcome this by breaking the layers into single parts, that is eddy current losses. And so in the iron losses also we have energy loss in the form of heat. Okay, so next is hysteresis losses. So as I told you, here what happening, when the current is flowing in the primary coil, we are having the magnetization of the core. When current is not there, we are having the demagnetization. So because of this magnetization and demagnetization, in the hysteresis loop, the energy is lost. So that energy completely is equal to the area of the hysteresis loop. So by minimizing the hysteresis loop area, we can overcome these losses. And the fourth one is, in the transformer, the layers, whatever the layers are there in the laminated core, they will vibrate, and that vibration will leads to a noise, that is magnetostriction effect. So because of this, a mechanical energy is lost. Losses takes place in the form of mechanical energy. So that is called as what? Vibration loss due to vibration of the core. So in the copper loss, we have energy loss in the form of heat. In the flux leakage loss, we have energy loss in the form of electrical energy. So in the iron losses, we have the energy loss in the form of heat again, and in the fourth part we are having the energy losses in the form of mechanical energy. So these are all the types of energy losses taking place in the transformer. It is important part. Okay, so I hope you have understood the energy losses in the transformers. Okay, so last concept we are remain with is how to use the transformer. Means, as I told you, we are having the step up transformer, step down transformer, which will help us to set the value of current, which means to set the value of current and voltage. They will help us, as I told you. Okay, so when to use the transformers effectively. Okay, so in generally what happens, whatever the energy we are using, that is produced in the power station. Yes or no? Power stations, you have nuclear power plants, all the things. Power plants, I told you in the introduction of AC only, I told you. So whatever the energy we use, that is produced from the power station. Okay, so power station, from the power station to us, means what are we are the consumers. We are consuming the energy. So from this power station to the consumers, the electrical energy should pass. Yes or no? Means one power plant, nuclear or hydro or anything, they are producing the electrical energy here, and we want that energy to our houses or shops or any industries. We want that energy. So from that power station to consumers, the electric energy is passed in the form of what? Wires. Yes or no? In the form of wires only we are having. But what we have to think now, these wires are having the resistance R. Yes or no? They are made of coppers. Okay, so they are having the resistance R. So because of this resistance R, whatever the current is flowing here, I, it will lose for some extent. Means there is some part of wastage in that current. Yes or no? So electrical energy, while passing from power station to consumers through the wires, there occurs a waste in the energy, or there occurs a loss in the energy. Yes or no? So hence, during the long supply of current from power station to consumers, we have to think of some important points. How to get the current effectively from the power station to the consumers without any loss. Okay, so this long distance AC supply, alternating current, because as you know, whatever the current we are using in our homes is nothing but AC. So this long distance supply of alternating current depends on two things. It depends on two things. First is what? Resistance of the wire. Resistance of the wire. Okay, and second is the current. Second is current, means resistance of the wire is R, and square of the current I square. Okay, I square. Why? Means whatever the wastage in the energy taking place, that is takes place in the form of heat energy. And what is that heat energy? That is I square R T. Okay, means from the power station to the consumers, whatever the current is coming, AC is supplying that. In that we are getting some energy waste, or we are getting some energy loss, and that energy loss is in the form of heat energy, and that heat energy is nothing but I square RT. So what I am telling here, the power loss during the long distance supply of the alternating current from power station to the consumers depends on two factors. First is resistance of the wire R, and square of the current I square. Okay, so now look at the first thing plus. What is the resistance of the wire? Means, as you know, resistance of the conductor is nothing but R is equal to rho L by A. So if you want to get the effective amount of current at your place, so you can get the energy, or you can get the alternating current without any loss if you decrease the resistance. Understood? If in this wire, if you decrease the resistance, you can get the effective amount of current at your place. So how you can decrease the R? Because you know R is equal to rho into L by A. So we can decrease the R. We can decrease the R by decreasing the length. If you want to decrease the R, length should decrease. Length should decrease means what? Between the power station and consumer, there should not be a much length. Means they should be nearby. So, but that is practically impossible. Na? Means if you are having the power plant somewhere in the Kaiga, somewhere at the hydral power plants, nuclear power plants, so many power plants are there. So they are not near to your home. So if you want to get the high amount of current, if you should decrease the length, but that is practically impossible. So this plan fails. Okay, so either you can decrease the length, or also you can increase the area. Understood? Because R is equal to rho into L by A. You can decrease the length so that R also will get decreased. Okay, so but that is not possible. So to decrease the R, you can increase the A, which is inversely proportional to R. So how to increase the A? How to increase the A then? Okay, because first plan failed, because the distance between the power station and the consumer's home is fixed. You cannot decrease it. But the second plan is what? Increase the A. How to increase the A then? Okay, we can use the thick wires. Whatever the wires you are using here, if you use them thick, means what? Increase the A, increase the area of the wire, means what? Thick wires you can use. Means thick means how much thick you can use. Okay, there is also a limit for the thickness of the wires, but it is not economically supported, because if you start increasing the thickness of the wires, the cost of manufacturing the wire also will increase. Okay, so that is also very difficult to make. Okay, so here both the plan failed. Means to decrease, means to get the current, to get the effective amount of current to your home, you thought of decreasing the resistance. So to decrease the resistance, what you have to do? You have to decrease the length and increase the area. So the in decreasing the length is also not possible, and increasing the area is also not possible. So this whole idea got failed. Understood? Means to get the effective amount of current, effective amount of AC supply to your home from the power station, the decreasing the resistance is not the way. So this plan failed. So we are remained with the plan B. What is that? Current. Okay, the second factor is what? Current. Means to decrease the power loss. To decrease the power loss in this AC supply, the option we remained with is decrease the current flow through the wires. Means what? Decrease the current flow through the wires. Understood? Means what? You want to get the high amount of current, but I am telling decrease the current. Means what? From the power station you want the higher current, at your home you want the higher current, but during this transformation, during this transmission, you want a less amount of current, so that it comes to your home without any energy loss. It comes to your home at very fast rate. Understood? So how is this possible? So how is this possible? Means from here to here you want the current, but during the transformation you don't want the high amount of current to pass here, because if you supply high amount of current, there obviously occurs the energy loss. So how to overcome this situation? Yes, it can be overcome by using the transformers. Understood? It can be overcome by using the step-up transformer. Step-up transformer. So what step-up transformer will do? I told in the last class, the step-up transformer will convert the low alternating voltage at high current. Low alternating voltage at high current is converted into high alternating voltage at low current. Understood? Yes, so you can use this situation here. Means low alternating voltage at high current is converted into high alternating voltage at low current. In turn, the step down transformer, what it will do? The high alternating voltage at low current is converted into low alternating voltage at high current. So whatever the electrical power generated at this power station is applied to the primary coil of the step-up transformer. Understood? Step-up trans means I will draw the diagram here. See, what we can do. See, see. So what is this? Initially we are having the power station. We are having the power station. Okay, so this is the power station. So from this power station we are getting the alternating current. Okay, so this alternating current we should fed this to the primary coil of the step-up transformer. Primary coil of the step-up transformer. Okay, so now this is the iron core we are having. Okay, so this is the secondary coil. Again it is transforming. So this is what step-up transformer we used. Here we used step-up transformer. Okay, so let continue the thing. Whatever the output of the secondary transformers there na, that will supply the higher voltage. Yes or no? That will supply the higher voltage. So from this power station, the low current at high voltage is converted to high current at low voltage now. Understood? This is the work of this step-up transformer. Now this low current at high voltage is carried by the transformation wire, or transformation lines. Okay, that is the substation, whatever the substation near to the consumer's house. So after this transformation, again we have to take this to our homes. We have to supply this to our homes. So again we at that time I am using one step down transformer. Means see here, and that output, whatever load is there, that is given to our houses. Okay, what I am doing here, I will tell you once more clearly. Okay, listen to it clearly. Whatever the electric power generated at the power station is fed to the primary coil of the step-up transformer. Understood? And this output or the secondary coil of the step-up transformer supplies a very high voltage at low alternating current. Understood? At low alternating current. Okay, so this low current at high voltage is carried by the transmission wire, or transmission lines, you can say. Okay, so this low current at high voltage is carried by the transmission wire to the substation near to the consumer site. Okay, so this hence here the whatever the power loss is produced, that is considerably decreased. Understood? So that is the wires which are carrying the low current at high voltage, they are transmitted to the substation near to the consumer side. So hence here a maximum amount of loss is decreased. Understood? So after transmission to the substation, here we will use one step down transformer. So that step down transformer that we used, that step down transformer will convert the higher voltage to the whatever required for the house. means here it is coming in the form of higher voltage. So this step down transformer will decrease it, because what is the work of the step down transformer? It converts the high alternating voltage at low current into low alternating voltage at high current. Understood? So whatever the high alternating voltage is coming, that is converted into low alternating, because here step up transformer has increased the amount of current at a very high extent, means whatever the current coming here is very high alternating voltage, so that is decreased by the step down transformer to low alternating voltage, because whatever the amount of voltage is required in this home, that is given out by the step down transformer. Understood? So as I told you, from the power station, so what I'm telling, from the power station where the current is produced to our homes where we are using the currents, the transformation of current, the process of transformation of current is very difficult. So to overcome that difficult, we use the transformers. Understood? So what I discussed here, use of the transformer for long distance AC supply. What is all the discussion? This use of the transformer in long distance AC supply. Whatever the problems came there, so from the power station to consumer, if you want to pass the current effectively without any losses, there we are getting the problem. We are getting the problem in the form of heat energy loss, so that is I square RT. So we thought of decreasing the resistance of the wire or decreasing the current, but decreasing the resistance of the wire is not possible, because you can't decrease the length and you can't increase the area, so this plan failed. But decreasing the current at the place of transformation is happened by using the transformers. Okay, so whatever the high amount of current produced over here is converted into low, and it is transformed. No, step up means whatever the current is produced here is increased at a very high extent, and it is passed, and at the time of receiving at the place of consumer side, it is again stepped down by the step up transformer. So in this whole process, by using the transformer, we have supplied the AC supply in the long distance. How means? The electrical power generated at the power station is fed to the primary coil of the step up transformer, and the output of the step up transformer supplies a very high voltage at low alternating current, and this low current at high voltage is carried by the transmission wire to the substation near to the consumer side. Hence the power loss is very much decreased. So after submission to the substation, a step down transformer is used to step down the AC voltage to the value which is safer for the consumer, safer for the distribution. Okay, this diagram will show that thing. So thus transformation, so the transformation of the AC through a long distance can be made easily using the transformers. Understood? Hence the transformer is an electrical device used for economical transmission of the electrical energy to very long distances. Understood? Means without much loss, without much cost, we can transfer the electrical energy from one place to another place at a long distance by using transformers easily. Thus, transformer is an electrical device used for economical transmission of the electrical energy at very long distances. Understood? This is the effective use of the transformer. So here the discussion of the transformers finishes. Okay, so with this I conclude the theory part of the alternating current chapter. Okay, so from the next two classes I will solve some numericals related to alternating current, and I will give you the notes also, and with this we will sum up with the chapter alternating current. Okay, so as I told you, while looking for the next class, please keep a list of the formulas coming in this chapter. That's why while solving the problem it's easier for you. Okay, so in the next class I'll solve some problems regarding to this and we will end up with this chapter. Okay, so I'll stop the today's class here only, and please next time prepare the list of the formulas and be ready with your book and pen. We'll solve some problems, some simple problems by using the formulas in the alternating current chapter.